Let me get started here. My name is Steve Gordon, and I'm a member of the board of the CHPC Education chapter. And it's our pleasure this morning to have a group to talk about an interdisciplinary program aimed at computational and data science. So without further ado, I'm going to start off by introducing Linda Ackley, who will give an overview and get us started. So Linda, I'll turn it over to you.
Thank you, Steve. Okay, it says host has to allow me.
Okay, just sorry about that. Give me a second.
Okay.
Should be okay now.
Yep, we're good. And thank you for having us speak today. I just would like to introduce the group. This is a project called C2Exchange. It's an NSF-funded cyber training project. We're in the third year of our grant. We all have 4 speakers to talk about their experiences within the exchange, but I'm going to first introduce it because there's a few more schools that are involved. So our agenda today is I'll introduce the C2Exchange concept. Then you'll hear 2 presentations on the actual course development and implementation at their institutions. We've got a person speaking about the use cases, and then an example of the discipline-specific minor. And we'll talk a little bit about our plans versus what's actually happened so far, and then take questions and answers, do a Q&A. So the very first thing, I just want to give you kind of a perspective of the institutions that are participating. And this is a collaboration that also includes Ohio Supercomputing Center and Kate Cahill, as is actually the lead PI, and SURA, where I'm from, Southeastern Universities Research Association. I'm also a co-PI, and the 2 OSC and SURA together are facilitating this. Before I jump into who's participating, I want to acknowledge Steve Gordon, because this actually is a concept that we worked on together when Steve was at OSC, and we had a workshop back in 2014 to look at how do we advance computational science at minority serving institutions. And so this has evolved. We were able to get a cyber training grant, and we currently have 5 institutional partners: Bethune-Cookman, Clark Atlanta, Morgan State, Southern, and University of Puerto Rico at Mayagüez. As you can see, there are several different types of institutions. There's 4 HBCUs, 2 are private, 2 are public, and then UPRM is a public Hispanic serving institution. This is the enrollment information from when we originally submitted the grant several years ago. And this is really just to give you an idea of how many students could be reached by the implementation of these types of programs at these schools, and particularly students that are identified as underrepresented within the field. So our goal for the project is to help them quickly build undergraduate computational and data science minor program certificates and credential offerings. And the way we do that is through shared expertise, shared courses. We have a shared course management platform. We do a lot of collaboration in terms of the development, implementation, and management, as you'll hear from their presentation, the following presentations. And we do facilitate access to advanced computing resources so that there are resources available for student assignments. Just to set a stage, you'll hear more about this as each presenter speaks. We are using and following the competencies that are identified at HPC University, and we've chosen to start with 4 courses, and 3 of them are foundational, and 1 of them is a discipline specific. And again, each of the presenters will go deeper into that. So with that, I'm going to turn it over to Ana Gonzalez, who's going to talk about her experiences in developing and implementing her course.
Okay, so good morning, everyone. And as Linda mentioned, I will be talking about my experiences in creating and implementing an introductory course in modeling, simulation, and computation at the University of Puerto Rico at Maya West. So this is the outline of the presentation. And I will start with the origin of the course, the justification, course description, the textbook that was selected, competencies covered, course objectives, resources developed, and course delivery, in-class time, and some final observations. Okay, the course, as Linda mentioned, was developed as part of the C2Exchange, which is an NSF-funded pilot project for computational and data science literacy curriculum. Exchange. So the University of Puerto Rico at Maya West is the co-lead institution together with Southern University for developing and offering the course. So how to justify the course? Let us try to answer the question, is there a gap in the curriculum? Note that one of the goals of offering the course is making computational and data science literacy available to a wide variety of students, students from different majors. And currently, the courses here at the university available that address the topics of modeling, simulation, and data science have multiple advanced prerequisites. So it is hard for many students to take those courses. And sometimes the students that do have the prerequisites cannot fit the courses in their curriculum. Plus, these courses are offered randomly, depending on student enrollment and instructors' availability. So since this course has only college algebra as a prerequisite, it is accessible to many students and can be taken to fulfill an elective course in their major's curriculum. It could also be taken as a course to fulfill the math requirement in some majors. So in conclusion, for the justification, this is a foundational course that will allow to infuse competencies of computational science to the undergraduate curriculum, and at the same time attract students from all majors. Also, it will help students become aware that modeling and simulation have become an essential part of the research and development process in physics, biological, and social sciences. The course can also prepare students to work in undergraduate research. So in terms of the course description, no programming experience is required. This is an introduction to the principles of modeling and simulation, a progressive introduction of programming principles and skills using Python, and an application of programming skills to the solution of different classes of models. So in terms of the textbook selected, it is Introduction to Modeling and Simulation with MATLAB and Python. And it has been a unique experience and a very special experience to use a textbook for which I know one of the authors. So Dr. Gordon, thank you very much for an excellent book. Some unique characteristics of the book is its just-in-time approach to introduce programming concepts and an excellent review of the history of computational modeling and its contribution to the advancement of science. So this is a list of the course objectives as stated in the course syllabus and can be summarized as saying that the course motivates the students and provides a background for more advanced modeling courses. In terms of what the students will be able to do at course completion, the course content focuses on meeting a set of basic modeling, simulation, programming competencies that were developed as part of several NSF grants. This can be found at the link shown, and this is the same link that Linda mentioned in her introduction. So the competencies that were covered in the course are listed in the syllabus. It includes a list of 15 items. Here I have included the first 4 on the list. Okay. So also the syllabus includes a mapping of topics and corresponding competencies. Here the first 3 of 15 items of the list are shown. Okay, so the class materials developed consists of videos, practice exercises, walkthroughs, multiple choice questions, recorded demonstrations. The resources were made available through Moodle. And I would like to acknowledge the support of the Center for Distance Education at UPR at Maya West, which guided me through the process of developing instructional material. All these resources were developed prior to the pandemic. So this experience was very helpful for offering courses online during the pandemic. It allowed me to help other colleagues with less experience with this kind of developing. So coming back to the course, new material was presented in cycles of 1 week. So at the end of the cycle, the students had to take a quiz and submit homework or do oral presentations. And also the final exam was a project. So the course has been offered 2 times. The first time in blended mode, the second time in online mode. Each time with an average of 15 students. The first time it was in blended mode. So in class, the students could work at their own pace, work in groups or by themselves, and ask questions to the instructor. The second time, which was online, they formed virtual groups. Their oral presentations were done using audios that they recorded, and office hours or virtual office hours were done through Teams application. The course is presented in a structure that encourages self-paced, and the end of cycle quizzes allowed students to keep up with the material. The audio that the students had to submit forced the students to reflect about their work, organize their thoughts in order to prepare a script before recording. So in blended mode, it was much easier to give feedback. It was mostly done face-to-face. However, during the online mode, even though students could use Moodle chat, forums, virtual office hours, the main feedback was done when grading. The main feedback was done when grading their homework. So for the instructor, it was very time consuming. And also I think that the students appreciate more timely feedback. So in terms of, for the future, the next step is to develop a computational data science literacy concentration that will include 4 courses. So this course will be included, the modeling and simulation and computation course, a course in introduction to statistics, the visualization course is currently under construction, and an update of a course that will include some materials from the Computational Linear Algebra course. So with that, I think we can move to the next topic. Okay, so
you'll have to stop sharing.
Okay. Yeah, let me stop sharing and okay.
I am going to start again myself, start sharing my screen. Am I sharing my screen now?
Yes, you are.
Okay. Again, good morning, everyone. My name is Alam Tinuri, and I will skip talking about the C2Exchange because Professor Ackley did a nice introduction. I am part of this wonderful, I would say, project representing Morgan State University. And I would like, for people to know who we are. I will skip our collaborator because already somebody presented the universities and colleges who are sharing in this project. So what we did at Morgan, we did develop a course which we called Linear Algebra 2. Which means like we already have a linear algebra basic course, and it is basically the mathematics for machine learning. It's not really training to do machine learning, it's the mathematics needed to do machine learning from several concepts from linear algebra. So Morgan State University, we are in HBCU, the largest HBCU at the state of Maryland. We are about 7,700 students, and actually, maybe I moved quickly. We moved already from R3 to R2 classification. And I would like to talk a little bit about our department, the Department of Mathematics. Actually, recently, I would say recently in 2011, we had, we were approved to start offering a PhD program in industrial and computational mathematics. And then when we look at, what we are here, like when we talk about computational mathematics, it means we had a vision of moving the department into that arena as well. So we have a picture always, we show off that the math department is housed in Carnegie Hall, which is the oldest building on campus, and it was built in 1919 with a gift from Carnegie in 1919. So what is the goal of Morgan State for the C2Exchange, and what is our input? As I said, we developed a linear algebra course, which is actually mathematics for machine learning. And as a big goal for us, we would like to prepare our students to be active members of the STEM workforce, and especially at the math department, of course. So we developed a computational linear algebra course that we were planning to share with several MSI partners, and we will talk about how it was modified to accommodate the needs of these institutions. And locally, our goal to develop a certificate in data science and computational mathematics. I think the work on a certificate in data science, it is in progress between us and between computer science. So I don't know to whom am I preaching right now, but I would like to give quickly, our short catalog description, which is limiting us to 40 words. There is a lot of right, but we are limited to 40 words, and I am sharing it. I don't think I need really to read it. And if you want me to read it, I can go ahead. So basically, we would say, we're giving justification, what is the role of linear algebra. And I do have a larger, I would say, an expansion of I would say, description of the catalog. Why, justification. Why do we think that linear algebra is really important? And what is the role it's playing into, creating machine learning algorithm, and specifically analyzing large data, and as well as prediction. The topic, if anybody attending here is interested into the topics actually that we're covering like Hermitian matrices, quadratic form, positive definite matrices, because these are concepts that they were not covered before in a basic linear algebra. And we focus a lot on matrix decomposition. And when I talk about matrix decomposition, I am talking about singular value decomposition, principal component analysis, which they are really the building block, not some of the important building blocks for machine learning. And this is where most of my work is focused, right here, into matrix decomposition. I am going to share some of snippet from my long syllabus, and one would be, what is the course goal? And we talked about that. I said I would like to introduce our students to advanced topic from computational linear algebra. We want to give interpretation of matrix operation in the context of data. And this is where it's a little bit different. We're not going to add and multiply just for our rotation translation. We would like to do that in context of data. And as I said, we are going to apply matrix decomposition algorithm as well to work with data. And provide tool to build a broad mathematical foundation of machine learning, apply programming skills and computational, sorry, it moved. Now, I would like to say at Morgan specifically, we use MATLAB because it happens that we do have a site license for the whole university of MATLAB. It might have been expensive, but this is what we have. Engineering school, I think, provided the university with this capability of having every student having access to MATLAB. And actually, I'm using it a lot in this course. I think, and I don't know if I should say that in the future, if we have time, because always, we have big goals. I don't know how much we can achieve. And, Python. I know it's important, but for me, for now, I am holding on. And it is in the work. It is in the future. And I had actually I make always my presentation a little bit active. I wanted to ask, I will ask Professor Anna at the end, how is she managing, you know, to train these students to, you know, work with MATLAB and Python at the same time? Because for me, I am not requiring students showing up in my class to have any background, even in MATLAB. And this is something that's always lacking in many of our departments. So we do all these mathematics, you know, proof and everything. And at the end of the day, our students ended up not being able to use even like any software to plot a function. Things, of course, are changing now. And this is why we're talking about STEMs. We're talking about strong theoretical foundation, but we would like to move it to data. So this is the course goal. And one important thing at the end, I will talk about that as well, do some kind of modeling application at the end of the day. And maybe this might be right here. Right here would be, I should have made it a little bit bigger. The application, these are the general application to statistics, data analysis, web search, you know, signal imaging, error detecting codes, page ranking. So this is the advertisement, what we can do, you know, but I don't think I can do all of that. I will share exactly what I have been doing, or what I do at the end of my presentation with some of the application. I'm going to talk about my experience, you know, how the class was offered. I offered the class, it wasn't in the context of the project itself. I have been teaching linear algebra and application to linear algebra at the undergrad level, and it is a advanced graduate engineering course as well. So I worked a lot before, and actually I grew myself through the experience to develop the course to be offered as C2Exchange course. My experience, actually, I would like to compare it to Professor Gonzalez. For the C2Exchange, I would say when I was part of the project, I had to offer it last fall totally online. I don't want to talk about online. I offered it remotely. What is remotely? It means I was meeting the students. It's in undergrad course, 3 credits, Monday, Wednesday, and Friday at 2 o'clock per se. It was like teaching. I would use OneNotes. I would use live action, and the input and output was live. Of course, we had extra office hours. So this was the mode of the mode I had to use. But before, because I don't know, for me, I started I don't know, online teaching and developing my skills about 10 years ago. Before that, I did some kind of a hybrid classroom. And the reason I needed to do a hybrid classroom, because the programs and readings and having hands-on in a computational linear algebra course takes time. It's not easy for the professor to cover everything in this 1 hour. So sometimes 1 hour would be left to the students to do guided work and group projects. And actually, this is a plan. You can take your time because it is recorded, you know, stopping your video and look for people who are interested into mimicking or having ideas of the work we do. You can do that. I like, and this is really dear to my heart, and this is really special for our teaching. Years back, maybe in 2014, we got a grant using something called culturally responsive teaching. And with Professor Ackley, we had some kind of very nice meetings and workshops about how to use computational mathematics for social justice. So these two, I would say, I don't know what to call them, you know, concept, you know, guiding force, guiding me toward developing the application that is of interest, that benefits, that help my students to grow. And these are the two things that I have in mind. culturally responsive teaching. What it means, you know, like you see it, and I was inspired one time, like long time ago, with some study done inside MATLAB. I'm not paid to advertise MATLAB. It's just, it happens that I am using it. So analyzing quality of life in US city using principal component analysis. In my class, I teach principal component analysis. I want to live a life. And you know, when we talk about cities, our university happened to be in a city, and always we have in the news things about our cities, and the students are interested into our cities, you know, and what's going on. So I share with the students the general work that was done with MATLAB, math work, and this is inspiration for the students to go ahead and do some work on their own, of based on the work that I do in class. This is 300, 400 level class. So it is where you train your students to develop their mind and put them in the path to start doing research and graduate school and so forth. So, so these are things that really I did and I do. It's not anymore the theoretical list that I have for 15 topics. So one question, and this was inspired by the lead story from Michigan, is Baltimore water quality really on the decline? This was the title of a work that a student did. Okay, I am not saying it's in decline, and the reason she's asking that, because for years, Baltimore was always boasting that we do have the best water quality in the United States, which was proven by calculation and by, you know, by science, I would say. It wasn't only boosting without, you know, having science. So the students really wanted to ask this question, and she wanted to research it. And as you see, when I talk culturally responsive, that's it. I'm talking about social justice. Yes, is Baltimore quality water? It's, you know, it's good enough. We're talking about social justice. We're talking about crime, about transportation, and we see what is impacting the life of the city. So we can go ahead and suggest, you know, more public transportation to this area or that area. We will find weak points. So please, Professor Ackley, I don't see time. If I am talking too much, stop me. And one thing, we know that everybody talks about Baltimore Inner Harbor pollution. Is it polluted or not? It's good, you know, like it is good for some activity, but of course it's not good maybe for swimming. We need to study that. And actually, the data we collected real data that we do have many active people, you know, collecting weekly data. We are big in the sciences in Baltimore. So we talk only not about the harbor. We are going to talk about the Falls, you know, Falls River, and because it goes through the city. And while going through the city, maybe there is some kind of dumping of, I would say, not clean water. This is where I leave it. So these are projects that involve the students, you know, get really involved into that, because we do have a high percentage of our students from Maryland. But you don't have really to focus in Baltimore. You know, you can focus. You are from Ohio, you go look around, you know, what is of interest to your students, and you work on that. So when I talked about analyzing the city, it wasn't only local, and I'm going to move to other things. One of the projects I worked on for a student who took some kind of format of the course, she worked on the spread of the COVID-19, and it was in the fall, towards the end of the fall. And she used vector support machine, a topic that sometimes I can teach in a course of linear algebra, sometimes I cannot. Years before, and it is in the advanced version of this, a student worked on optical character recognition, and he ended up doing research in cancer. It was trained in my class, you know, to work on optical character recognition, A, B, C, D, and he moved to cancer.
Okay, Dr. Tanuri, we kind of have to move on so the other
Okay,
people can
okay.
get a chance.
This is why I wanted you to let me know. So one thing, I am making the students recently read a paper in topology, using topology, and this is new, how to work through that. And I want a minute to share what I did with the group, with the C2 group. What we did when I was developing the course, I had several meetings with the University of Puerto Rico and Southern University at the course of the development. And recently we started to share, after the course was developed and ready, we developed a module, and we are sharing models, and we are sharing projects among each about our institution. We invite each other to give talks about these courses as well. And the course sharing technology, we would like to thank Ohio Supercomputing Center for hosting, I would say, as the course material for computational linear algebra. Thank you for reminding me about time. I should have timed myself. Thank you. I am passionate about what we do. Thank you. I'm done. I have to give hold on one second. I'm stop sharing. And
Okay. Rachel.
Professor Friendly.
Okay, let's see. Good morning. Okay, it's not in share mode for you all. Give me one moment. Okay. I'll try that one a different way. My apologies. Desktop 2. I think you lost my screen again. I apologize. I'm working on multiple screens and this doesn't want to. Okay, one more time. Okay, my apologies. I've hooked up a screen of screens and Zoom is asking me to be specific as to what I want to share. All right, thank you all for joining us today. Today I will be talking about the C2Exchange from an implementation point of view. I am Rachel Vincent Finley. I am at Southern University in Baton Rouge, Louisiana. So I'll begin with a introduction of my university. I'll provide an overview of the Southern University system and then briefly discuss C2Exchange implementations of Introduction to Modeling and Simulation and the Computational Linear Algebra course that you all have just heard about, and then briefly discuss some plans for the future. So Southern University and A&M College is a part of a university system. We are a historically Black college and university system, the only such system that exists in the United states. We are housed in Baton Rouge, New Orleans, and Shreveport. I am housed on the Baton Rouge campus, which is our flagship campus. We also have the Law Center and the Ag Center on the Baton Rouge campus. We have campus in New Orleans, Southern University in New Orleans, and that's a four-year institution as well. And we have the Shreveport campus, Southern University at Shreveport, located in Shreveport, Louisiana, in northern Louisiana, and that campus is a community college campus, so 2-year degrees and technical degrees. So my focus is the Baton Rouge campus. This is the Baton Rouge landmass off of the Mississippi River. I'm housed in the College of Sciences and Engineering, specifically in the Department of Mathematics and Physics, and the subset is the mathematics program. My purview is all of the levels. I currently serve as the Associate Dean for Academic Affairs in the College of Sciences and Engineering, and I'll talk a little bit more about that in my plans for the future. And my academic discipline is mathematics, particularly applied mathematics. So my motivation for being a part of the C2Exchange, besides the fact that I've been working with Steve Gordon and Linda Ackley since arriving at Southern University, and the push for these certificates or concentrations in computational science. Also my interest in mathematics. I had interest in moving the mathematics program into offering at the undergraduate level a concentration in applied mathematics. So at the sub-level of the department in the program, and then thinking more largely to the College of Sciences and Engineering, and how these the college can affect not only within our college, but the entire campus, in thinking computationally, and how our technical resources can help students in engaging their subject matter more in depth. And again, some of that conversation will come out in our plans for the future. So I want to speak a little bit about our implementation. So we heard from Ana Gonzalez concerning the development of Introduction to Modeling and Simulation. And I was able to offer the course in 2 settings here at Southern University. How I offered the course prior to going through the curriculum process with our university, I offered it in a slot called Seminar in Mathematics. So here I list the course description for Seminar in Mathematics. Seminar to Mathematics is a topics course, so the instructor picks the topic, and for the catalog description, it has prerequisites, the prerequisite of Calculus 2. You have to earn a grade of C or better, or have the consent of the instructor. The consent of the instructor piece was the flexibility that I needed to offer Introduction to Modeling Simulation in this slot, because as you heard from Anna, the prerequisites for the Introduction to Modeling Simulation is at the college algebra level. So that would be earlier mathematics, which would allow a broader class of students to participate in the course. And of course, the topic selected for the seminar was the C2Exchange Introduction to the Principles of Modeling and Simulation. We utilize the textbook as outlined by Anna. So in our implementation, we had a small group of students. The first implementation was in the fall of 2021. And in that implementation, we had 2 mathematics majors in the course. And these actually were very advanced math majors. So what was interesting about implementing the course, as some of the conversation Alam was mentioning earlier, in mathematics, we offer them the theory, we offer them the practice, learn how to write those proofs. However, a lot of times there's a disconnect with, okay, now what do I do with this? And the students ask all the time, you know, when you're going through the course, okay, so how is this relevant? what are we going to do with this information? So in the mathematics program, our students are required to take computer science courses. So they learn about programming, but again, there was a disconnect. They learned about programming in the programming box. They learned about their mathematics in the mathematics box. And this course allowed us to talk through fusing these things. Unfortunately, this conversation came at close to the close of their curriculum. But with this first set of students, I was able to we had a lot of great conversation about how this can be infused into the earlier part of students' curriculum. So it was very helpful in this setting with this first group of students because they were very vocal in what they felt would have been more helpful to them as they moved through their mathematics curriculum. And generally, they offered some insight about their colleagues in the College of Sciences and Engineering. So this first implementation, we went through the modules as developed by Anna, but since these were advanced students, we actually went through the course and the textbook very quickly. So the students used it as a boot camp in Python. So they had not used Python before, so it was a boot camp in Python, and they used the exercises in the textbook to on-ramp them. So the students actually did all of the exercises as outlined in the textbook. They did writing, they looked up information with data, they went through the whole process of learning Python, uploading information, providing plots, things of that nature to visualize their mathematics. And then the second part of the course was project-based. So the students went to the last chapter of the textbook where it outlined some projects. They picked a project, altered the project, and then implemented the project. So the two students, I list the titles of their project. The first student did the moose and wolves population, where we're looking at the predator-prey model. And she looked at park, where there were actual moose and wolf population information data provided, and the student analyzed that. Another student was interested in stochastic models, and the twist this student was interested in was the traffic pattern. Why was it that he always stuck in traffic at various locations? And the student collected his own data, used some of the data from the Department of Transportation, but also collected his own data to build out stochastic model for traffic. When he said from home to work, he was really interested in quicker ways to get from home back to campus so that he could take care of academic and work-related duties. This student was a naval ROTC student. He is now a commissioned officer, and he was very serious about studying the traffic patterns so he didn't have to spend as much time in traffic. The second implementation of this course is currently in progress, and given COVID-19, we are meeting remotely, but we are meeting synchronously. This is an independent study. One student is enrolled, and again, this is project-based, and the student, again, is an advanced mathematics student who is currently working on a project. So for this course, again, it has been used as a boot camp to provide the student information about Python and the application of Python, connecting the mathematics to the coding, so that the student is then able to use visualization and really break down some of the mathematics concepts and put them together for in a larger context. The student has not yet submitted her course proposal, but she has various interests. One being that she's a softball player, so she's looking at some statistics with respect to gaming and specifically her interest in softball. but she has not again settled on a topic, and that is actually her assignment for this week, providing her proposal. But in all of these, in this whole context, the students are going through the whole cycle of modeling, where they're thinking about what are the appropriate parameters to select, they're implementing, and they're cycling back, okay, did this work, did this not work? They're creating flowcharts, the whole process as outlined in the course textbook. A second item that we are working with, the second course that we're working with here at Southern University is the Computational Linear Algebra course. The lead developer you just heard from, Dr. Alam. So as with Dr. Alam, here at Southern University, we have 2 linear algebra courses. This is a catalog description for the catalog course, for the course where we are implementing the C2Exchange linear algebra course. We list in our catalog's description that this course should be a good mixture of proofs and computations. However, in my observations, the computations piece is generally not as emphasized. The prerequisites for the course, as I noted, this is a second course in linear algebra. So the students go through the process of learning the introductory pieces for linear algebra, the terminology, the determinant, different items. And then the second course is supposed to go into more detail and provide the students with a deeper understanding of proofs and make the connection to how linear algebra is used in a larger context. The course is 3 credit hours. So my purpose for offering the C2Exchange course is that we need to revive and rethink this second course in linear algebra. Again, the current catalog description is as listed. My current implementation is considering modules from the C2Exchange. And I list here the course references that I used because the students already have a base in linear algebra, but I always want to offer the students various references, and these are open educational resources, the first 4. The first 3 open educational resources, sending them back to their linear algebra as points of reference. The 4th reference is a reference to remind them about their proofwriting background. And as we think through the computation, I also want them to think through the theoretical piece. Let's connect the theory with the practice. And the 5th reference is the application reference, as Dr. Alam has noted, the mathematics of machine learning. Now let's focus in on a specific application. So this semester, the spring 2021 semester, we are offering this linear algebra course, Computational Linear Algebra, under the umbrella of the Math 433 at Southern University. A small group, 2 mathematics majors. This is also project-based. And for the computation piece, the students will be using MATLAB to explore applications. So part of their on-ramp to MATLAB is from the MATLAB Academy. And Dr. Alam has provided a lot of wonderful applications and resources for students. Her passion for students has been really helpful in this process, in that she wants the students to be able to find resources, free resources where available. We know that some of our students are resource constrained, so we want them to have have access to those things that will help them in their educational growth, but will not they will not be hindered by monetary constraints. So a lot of our publishers and a lot of our vendors provide these academies, opportunities for the students to learn concepts under the free umbrella that walks them through information. And again, both Dr. Anna and Dr. Alam have provided us with a lot of resources that are out there. And started our repository, I guess how I would say it, a repository of information that will allow us to implement these courses in a nice way, and a way where we're not just implementing the courses and sending the students away, we're offering them a foundation where they can go back to these resources and learn more as they move into their next set of classes. So plans for the future. So I go back to my motivation for participation in the C2Exchange. We have interest in computational science concentration and certificate, and from my mathematics perspective, an interest in an applied math concentration. I noted that I currently serve as the Associate Dean for Academic Affairs in the College of Sciences and Engineering. So over the past 2 years, I started in 2017 in this role. I've not only had to think about the Department of Mathematics and Physics in my home, the mathematics program, but I also had to think of the other units within the college, the Department of Biological Sciences and Chemistry, Department of Computer Science, and our engineering disciplines, civil, electrical, and mechanical engineering. And from the purview of the college level, it's even more intense as I review curriculum, how we can bring together what we're already doing in a more collaborative way. And of course, it's glaringly clear that this concentration in computational science is something that will benefit the students across the college campus, and specifically within our academic college. So some plans include offering modules in support of honors college theses. So we're planning curriculum as set courses, but we can also offer these modules as independent study, in an independent study context. Our honors college students spend an entire year or 2 years developing their honors thesis, and these courses and information from these courses can be the foundational courses that prepare them for developing their honors thesis projects. Also, for professional development, I work with several research experiences for undergraduate students. Our students come from all of the majors within the College of Sciences and Engineering, and external students join us on campus. So we have professional development activities every week. Some of the students need to learn Python. Why not pull modules from the course and give the students boot camps over the summer in these activities? And I will be piloting, well, I've already started piloting that, but in a more formal way this summer, providing the students with weekly professional development using pieces of actually both courses, depending on the student's level. One course, they would be looking into Python, the other they will be looking into use of MATLAB. And finally, interest in sharing the courses across the Southern University system. The current work is concentrated on the Baton Rouge campus. However, we have some common courses, and particularly when we implement the introduction to the introduction to modeling and simulation, that course will be at a level that we can offer it not only on the Baton Rouge campus and the New Orleans campus, our four-year institutions, but it's at a level that we can also offer it to our technical school, community college at the Shreveport campus. So this is an opportunity for us to actually recruit on both of the campuses from our community college. And again, in speaking to some of the administrators, there's an interest to bridging the students with a computational science pull into the various college sciences and engineering disciplines. Thank you for your attention. This is my contact information, and I will hand the baton to our next speaker.
Dina, you're muted.
Yeah, I'm sorry. Good morning, everyone. As part of C2Exchange, Clark Atlanta University is offering the course Introduction to Computational Chemistry and Molecular Modeling. My name is Dinalan Tandabani. I'm an associate professor of chemistry, work in Department of Chemistry at Clark Atlanta University. What is Clark Atlanta University? The Clark Atlanta University is a non-profit private HBCU. It offers bachelor's, master's, and doctoral programs. We have an approximately 3,800 students enrolled every year. Established in 1988 by merging two institutions, Clark Atlanta University and Clark College, which has a long history. School of Arts and Sciences. I'm working in the School of Arts and Sciences, which has approximately 2,400 students. We have 4 schools, and the School of Arts and Sciences is one of the biggest schools at Clark Atlanta University. We have undergraduate students of 700 students in STEM. Okay. So Clark Atlanta University is the only university in the historic Atlanta University Center, which is located near in the downtown area. And in the Atlanta University Center, we have 4 schools, basically 5 schools together. We are very close to Georgia Tech and Georgia State University, right? So it is it's like a big pack of institutions in the downtown. Why do we need the computational courses introduced in undergraduate course, undergraduate curriculum? An improved curriculum, better use of technology in content delivery, effective academic support, and student success are essential for increasing the number of undergraduate minority students in STEM. This will give us an opportunity to have diverse computational experts in the future. Because now computation is regarded as an equal and essential element along with the theory and experiment in the advancement of scientific knowledge and engineering practice. And in every field, when you look at in science as well as engineering, computation is used. Okay. It's important to educate the next generation of undergraduate students to confront the challenges in computational and data science. By the support of NSF, myself as a PI developed, implemented as a course for junior and senior level undergraduate students, Introduction to Computational Chemistry and Molecular Modeling in the Department of Chemistry. This is for both chemistry as well as biology students. Any students in physics or even computer science, if they are interested, they can come and take the course. But this is more relevant to physics also, because physics use computational physics, and most of the time it's very close to each other, computational chemistry and computational physics. Through the NSF C2Exchange grant, this course is available to exchange with the partner institutions of other minority serving institutions. Full course or selected modules. So I'm going to show some examples too here in this presentation. This course, as I mentioned, this course was fully developed from the scratch and implemented, and the course syllabus was reviewed by experts, and experts also visited to the campus, and it was finally approved by our institution, because many of you know that course approval process is not an easy process in the institution. It took 2 year cycle, then almost 1 year to get an approval with the different stages. Now this course has a course number proper course number. It is in the course catalog of the university. This course is for the junior and senior level courses. It is for 4 credit hours. And what is this course? Is the brief description of the course. This course has the lecture and the lab to introduce the concepts of computational chemistry and molecular modeling and their applications in chemistry and biology. So very focused applications. Some specific examples were given to students to have a practice and explore. The main purpose of this course is to introduce some of the techniques used in computational chemistry and molecular modeling, and to demonstrate how these techniques can be used to study physical, chemical, and biological phenomena. The course is intended to prepare undergraduate students for higher education on computational-based research in chemistry, biology, or engineering by introducing the concepts and techniques used in computational chemistry and molecular modeling. I'll tell you some how this course inspired some of the students to take their career in computational based research, and they have moved to PhD programs in different schools in the past year and before that. Prerequisites for this course is the general chemistry 1 and 2, general biology 1 and 2, organic chemistry 1 and 2, and calculus, because at least I want to know that students should have at least some level of mathematics before they enter there. Most of the time when they come to the junior or senior year, they have finished, many students finish Cal 1 and Cal 2. Sometimes they struggle in organic chemistry, because without organic chemistry, they will not be able to draw the molecules. They may not understand it. But some of the students say that they better understand organic chemistry by studying the computational chemistry. So what are the course learning outcomes? There are 4 course learning outcomes. So 5 course learning outcomes. It's they apply variety of methods. That's very important. The students will be able to employ the concepts and techniques used in computational chemistry and molecular modeling. They'll be able to apply semi-empirical different methodologies, semi-empirical ab initio, density functional theory methods for calculations of molecular structures, energetics, and electronic properties of chemical and biological systems. Perform calculations for small molecules, the intermolecular interactions, conformational analysis of acyclic molecules, and build polypeptides. Report and analyze results of their calculations, because this is a very important point. Because if they do all the calculations, if they don't know what they have to do, how to do analysis of their calculations, then will not be helpful. Okay. By doing all these things, they will be able to apply self-confidently for higher education on computational-based research in science or engineering fields, data science, and be ready for advanced level courses related to computational chemistry and molecular modeling. It's a book we follow, Andrew Leach. This is a wonderful book. It's too big. Students get really scared at the beginning, but they understand after some time. C2Exchange grant, what do we do here? This course can be implemented by partner institutions as such, or with modifications, or only the selected modules. How can they do the selected modules, right? Physical chemistry course at undergraduate level chemistry program includes quantum mechanics and its applications. So the selected modules of Introduction to Computational Chemistry and Molecular Modeling were adopted to the physical chemistry course at Bethune-Cookman University. So Bethune-Cookman University chemistry professor contacted me. They said, okay, we want to take only the selected modules from here, which are relevant to the applications of the quantum mechanics. So it's students understood very well by doing this on and hands-on, and also by showing some specific examples from here. This course has a laboratory with lectures. Most important thing, what the feedback students said, that they really enjoy doing computational labs. So you can see some of the pictures, how students really enjoy in doing it. So by the NSF support, I could able to create the computational lab with the 15 computers right now, plus one instructor computer, all of them like really powerful. They can run really good calculations within, students can able to complete within 3 hours or 4 hours. If they need really, they can submit the jobs at any time and during the week, they can come and check in the lab. They really enjoy doing it, as I said, but when we had feedback from them, they said this is one of their best. They are waiting for the lab to come. Their visualization, they really enjoy. Some of the students said they understood organic chemistry very well. They understand the biomolecular structures very well by doing this visualization and doing the computation. This lab is not possible without the National Science Foundation's funding support. There are a lot of softwares used, and this is one of the good starting points for the students to move to the supercomputers, because the first, second, third labs, 3 weeks, after 4 weeks, I slowly switched them from the local computer to the supercomputers. Very important, I would like to tell you, these students have never used computers for science. Okay, they always mentioned that what can we use to do science for computers, because most of them, they don't know what is a scientific software is, right? So it is so good for giving this experience to the students. And some of them moved to their graduate program in computational chemistry, computational biology. And at least if they don't do full computation, they're using the computational skills in their research. In last semester, fall 2020, when I offered the course, it was a big challenge because we could not access the lab and there is no physical lab for us. So I had to do something, right? So I was thinking what I had to do for students to access and complete the lab. And most of the students, they don't have any experience on the Unix commands, and it's not easy for me to teach the Unix commands and come back and transfer the files. So I have chosen to move for the science gateway. So I contacted someone in science grade, C grade science gateway. And this is very nice. And I had some graduate program. I have some graduate students, and they helped me in working with undergraduate students in first 2 weeks, actually. So this is a web portal and desktop client. This is easy to do it. And this C grade has in operation since 2005. It serves over 600 scientists and students under 320 projects, okay? So why did I choose this? It's an easy job submission and project file management. It's easy. And students don't need to know the Unix commands. And they can just draw the structures in their laptop and try to see whether the structure is right, and prepare the input file and push the input file to the portal. Okay? From the portal, they can run the calculation. They have to choose which machine they want to run. And I have an allocation in the supercomputer, Exceed supercomputers. So I have tied up that allocation with the C grade science gateway. So my students can easily use those resources without directly going to supercomputer access through a secure shell client or putting. So they have run several calculations. You can see that one of the ways how the students that the input file is created. Just they have to choose which package they want to use, the calculation type what they want to use, then methods, everything like a click of the button. So once they do additional keywords, they may have to type it, right? Then once they get even some of the some of the results output file, they don't need to read the full output file. They get the summary of the output file. So some information they can easily get it. So they got really enjoyed doing it. So I asked the students to give the feedback, like a 3 minutes video, 2 minutes video, that those were amazing. They said this is one of the best things they learned. And their experiences, again, they stressed last semester too. Some of the students said, somehow this should be introduced partly in organic chemistry so that we can understand. We fail in organic chemistry, this will be really, really good in learning organic chemistry too. Okay. So their feedback is easily accessible, one-stop dashboard to handle multiple applications, projects, allocations, and compute resources. So it is really strongly, highly recommended by the students. So access to supercomputers, which is without the supercomputers, it is not possible for discipline-specific courses like my course, computational chemistry course, because we need still scientific softwares. If the open source software still, those are available in the supercomputers, we can still use it. And moreover, students can submit more than one job at the same time. If they are working in the lab, they can submit only one, maybe rarely second job. Then most of the time it may freeze after that, or may not be able to submit more than one jobs with the restrictions on the desktop or workstations at the within the institution. But with the supercomputer, students enjoy submitting like 10 jobs at the same time, so they can get their results faster and they're running. So without these supercomputers, it is not possible for me to do such courses. So what is the plan of having this big platform? For us, chemistry majors or physics majors, like Rachel mentioned, had only 2 students. We also have some similar situations. Chemistry, we may not have more than 7 or 8 students. Some of them may not be interested to take elective courses because there are more than one elective courses are offered. Then computational chemistry, I may get only 2 or 3 students. But luckily, since this course is designed for both chemistry and biology, I get students from biology. My experience in last semester, there were no chemistry students, but I got 11 biology students from biology department. They said they wanted to take my course. So by having the C2Exchange platform, we have a consortium. When we have this consortium, other schools also can take. So the course can be offered by showing the number of students from other institutions. Okay. Otherwise, our institution may say, oh, you have only 2 or 3 students. This is an elective course. You had to cancel. You can't offer. So when we have a partners, when we have a partnership, which is still possible to offer the course, this will be beneficial for other institutions as well as my students from my institution. So at the CAU, what this C2Exchange program will help? Building the capacity for computational and data science minor at MSIs. Okay, so I'm showing here a pathway to minor for a chemistry or biology or physics major at a CAU. So the C2Exchange courses, which is not possible for our institution to offer all these courses. However, our students can take these courses from other institutions. They can transfer, and these courses can be credited. And the home institution students can take programming for non-CS majors, which is going on, numerical methods, and other courses can be taken through this exchange platform. Okay, so with that, I would like to acknowledge my partners. Without these wonderful partners, this program is not possible. And we want to build this partnership even more stronger, and maybe with more partners from other MSIs in the future. I would like to thank the partners is the wonderful people like Kate, Linda. Always they are there to help us. Anna, Rachel, Raphael, Asma, Asama alum. So I would like to thank the C2Exchange program. It's a NSF, it's a help for building such a good partnership and to produce next generation minority students on for computational with computational skills. And also my HBCU program, which was a basis for building this infrastructure at the Clark Atlanta University. And I'm very thankful to Exceed. I use Exceed resources for both education, undergraduate students research, as well as graduate student research. My full-fledged research is going on with mostly dependent on Exceed. I tell you, 90% of my computation I'm doing with Exceed. The next one is a C-grade Science Gateway from Indiana University, very helpful. And still some of my undergraduate research students are using this. And Ohio Supercomputer Center for Moodle platform and all the help. This I end my presentation, and we are happy to take questions individually as well as the team. Thank you.
Well, thank you everyone for those presentations. This is a very interesting project. So I will open it up for questions if there are any now. And you can either unmute and ask it verbally or put something in the chat window, and I'll pass them along to the speakers.
Hey everyone, I was interested to hear from each of you what you think the most positive aspect of participating in this project has been for you.
Okay, let me go with the fast. Sam, I'm already muted. So the positive aspect is like we, as a team, we initially thought a little bit different. Okay, we are going to take the whole course, but it changed during the time of this. Okay, we can take a module and we can have a helping hand. Like, okay, I will do this section and you will do this section. And we are like really working together. That is a very important for success of this program. And so far it's so good.
You know, from my side, it is the interaction and knowing that I am not alone as institution. I know, of course, I have my colleague inside the department, but it's nice to talk to people, not only Professor Gonzalez, but other people in her school that she put me in contact with to see, you know, what we can do to develop the course, as well as, for example, being with Professor Vincent Lenley, what she needs, what she's doing. So it's like not feeling alone and having the backup for many institutions who might have, you know, same population, I would say, with our with our hopes and our struggles, I would say, to move our institution forward. So this is a nice thing. Thank you.
Well, for me, I concur with Alam also, that, you know, being able to collaborate and brainstorm with other people has been a big plus for me. And also just being able to create a course within the organization and have it available so that students to different majors have the prerequisites to take it. That those have been one of the biggest pluses of collaborating with the group of the wonderful people.
I would also echo what everyone has said. The collaborative effort in working with folks outside of your campus and observing the perspective of their student populations and thinking through ways in which we're all trying to engage our students. So the perspectives from different locations and the teamwork that goes into this. Everyone has their niche, and I think this group really pushes me, because we have a lot of very organized people in the group, a lot of great passion. when Alam joined the group, I was like, oh, wow, we are in for a treat because she has a passion that set fire to all of our passions. So I really appreciate that. And the whole group, Anna is super organized and very meticulous. Dina, he gets into all the minute details and I'm like, wow, okay, I need to talk to him a little bit more. And has me interested in chemistry, and that's not my discipline. So I see that this group really engages the students, their passion for teaching, education, and of course the other members of our group as well. We're really are pushing each other to really think beyond our specific disciplines and thinking through how we could reel in students. You know, I'm all about math, but I'm like, well, you know, Dina's right. You know, I can really get to these chemistry students and engage them more in their chemistry by looking at the aspects of mathematics that connect to their work. So that has been that passion, I think, has been a primary motivator, because this is a lot of work and we're all resource constrained on our campuses. We're asked to do more than our salary deems us to do, but that the passion for the students really keep us motivated. And I think the group passion really works to that end.
So we actually have an external evaluator for this project, and the evaluation from the first year that we offered and implemented courses, the shared expertise was really rated very highly. Also, though, the access to the advanced computing resources was also considered highly beneficial, you know, coming from that evaluation report. I would suggest also, we went into this with a model where people were going to share these courses and offer them on their campuses. And what we've actually learned is there's so many different models and ways they can implement the competencies, the modules, the exercises, as Rachel noted, like with her REU, as Dina noted that the physical chemistry could pick it up. He also noted the biology people are the highest consumers of his course and not the chemistry. So I also think learning about and understanding these models just expands ways that we can continue to push the CDS skills and curriculum across the institution.
I'd like to ask a little bit about organizationally where you see this going. I can see where you spread out to sharing modules and so on, but do you still see the possibility of actually sharing whole courses across institutions? And if so, are there barriers to institutions sharing courses with, you know, with regard to tuition payments or exchanges of courses between institutions, or have you gotten into that at all?
I think that you hit that one right on the nose. The funding issue is the barrier to sharing courses. The courses have to be offered on the campus, and the tuition has to stay with that particular campus. So the actual offering it, say, by one lead and having multiple people take it and share, you know, trying to pass credits back and forth, was kind of in the original thinking, and I think that's gone by the wayside. I think that we will have a governance and memorandum of understanding that ties us together but it's more about, I think the strength of this at this point is their ability to share the resources, share the expertise, and collaboratively build out modules and courses that actually meet the requirements of the individual institutions that are participating.
Great.
And one quick thing, we didn't feel that we are a loose group because of Professor Ackley and Professor Kahil. So it's like we felt the cohesiveness, even though somebody is doing, you know, organic chemistry and I'm doing computational linear algebra. Always in our meeting, we had this common thread and we didn't feel it's time for us to leave. And so I would like officially to thank both of them, because at one point it was like we were as a unit, you know, even though we were sharing expertise among 2 or 3 of us, but the whole group, and we are larger than the 3 or 4 of us that you see today. And actually they are very disciplining us bi-weekly meetings. So, you know, this matters. Thank you.
Are there any other questions or comments at this point?
I would like to add couple of more points for what Aaron asked that. We may be thinking sometime, yeah, we know the stuff, what's going on here, but when we have a team like this, other institutions work together, what is missing in our component is identified. And also the resources, because Linda or Kate always say that, oh, we have the resources here, we have the resources here. Always they tell us where we can find additional resources. Without that, it is very difficult actually. So that's a very important strength for us. And also our students, with the limited resources what we have, making them competitive to the future workforce is not that easy. So when we have the resources available with others and a lot of ideas, exchange of ideas that really help us to make our students very competitive. They are very fortunate to have, really the students are also fortunate to have such type of project.
Excellent. Well, let me thank you all again. This is a very interesting project, and I wish you well for its continued development. And as I mentioned earlier, this will be the recording of this session will be put on the YouTube channel of the chapter, and I will send you all a link once it's up. And if you would be so kind as to send me your slides, I will put those up on the webpage as well. So thank you all again, and all the best. Stay healthy, get a vaccination as soon as you can, and hopefully we'll be back to normal very soon. Thanks again.
Thank you, Steve.
Thank you.
Thank you,
Thank
everyone.
you.
Thank you, Professor Gordon.
Mhm.